Hi, this is week 3. Right now, we want to learn more about cement. So, at the end of this lecture session, you should be able to identify factors affecting the properties of cement and hydration process. And then so you need to know about the factor affecting the properties of cement. So that is first thing to identify. Second, you need to identify the hydration process. Because of the properties of the cement, so we do have hydration and we need to look in details the hydration process. Number two, you should be able to explain blended cement and its environmental impact. Number three, you must understand the types and classification of aggregates. So aggregate is actually one material that we mix into we mix to form concrete. And then number four, understand the properties and characteristic of aggregates. Again, in terms of aggregate is actually the rock fragment, the small rock fragment. So you know about the properties, you should know about the properties and the characteristic. The last part is to grade the aggregates. So this is the typical bag of cement. If you go to any hardware, you can actually buy cement, and when you open this bag of cement and you put on any container, you can find this is the texture that you get. So it's very fine material, so you must handle carefully, and when you mix with water it will show the binding properties. So that's why we need to use cement, water, aggregates, and then fine sand to form concrete mixture. So if you need to imagine what is the texture looks like, it's kind of clay, or if you have flour at in the kitchen, so that is actually the cement texture without adding any water. Okay, so try to understand this one. Factor affecting the properties of cement. Okay, the first factor is chemical composition. Of course, inside cement, there's a lot of chemical properties, and when this chemical react with water, so it will produce chemical reaction. And second factor affecting the properties of cement is the fineness of cement. So when you blend the raw material to form cement, we actually can control the fineness. And from fineness, it will explain under hydration of cement, the setting time, the soundness, and then less on ignition. So let's see all of that component in detail in terms of chemical composition. We do have differences in chemical composition, and this chemical composition could affect early and ultimate strength. So immediately you mix with water, that cement has early strength, and then after some time that cement will achieve ultimate strength. And then from the chemical composition, of course, heat will release, and then we do have setting time and resistant to deleterious material. So that is how you explain under chemical composition. So number two is the fineness. Okay, fineness is a measure of the sizes of particle of cement. As we can see earlier in the picture, the cement is actually fine in terms of fine. It's kind of powder, but that powder we can control the fineness. Okay, and then this fineness is expressed in the terms of specific surface of cement. So let's see this one. The more the fine the cement is ground, the greater will be its specific surface. So we look upon the finest cement. But of course, there's a lot of product in the market, so you must choose wisely. More fineness of cement, more rate of hydration and rapid development of strength. So with the fineness of cement, we can actually achieve rate of hydration, and of course the strength is developed rapidly. Fineness of cement can be carried out via sieve analysis through a 90 micron sieve. Uh, if you experience in any lab session, if you ever see the sieving pan, so that is actually content of mesh wire. So and then we need to do the sieving test, and whatever passing 90 micron sieve, that is actually the consistency that we want to find in cement. And then you have special surface area, for example air permeability method, and then we do have wetness stability method. Table 2.0 shows fineness of different Portland cement. So if you still not yet understand what is Portland cement, okay, most of cement that we can find in hardware shop, that one is ordinary Portland cement. And then this ordinary Portland cement have the specific surface about 2 to 5 meters squared per kg. For rapid hardening Portland cement, the specific surface area is 325 m squared per kg. And then you have low heat Portland cement is about 320 meters squared per kg. Okay, why the fineness is most important factor which determine the properties of cement? The first thing is fineness of grinding is a some important in relation of the workability of concrete mixes. Workability can be defined as the amount of mechanical energy or work required to fully compact concrete without segregation. So at the end of the day, we want the best quality of concrete. So fineness always related to workability of concrete mixes. Okay, how this affected? You can explain in terms of amount of mechanical energy. And if you have best quality of cement, so we can expect the work required to fully compact concrete without segregation. So you have better concrete mix. The end product of concrete is better with the good quality of cement. So next is greater fineness increases the cohesiveness of concrete mix. Okay, because we need cement to act as binding agent to all of the material that we mix to form concrete. That is why it, it is very important for the cement have the ability to bind, or what we call it as cohesiveness of a concrete mix. Fineness increases the chance of shrinkage cracking resulted from both cooling and drying of concrete. And then the last part, fineness and cement composition affect the compressive strength. So of course we do understand concrete have the high quality in terms of compressive strength, but you can increase this compressive strength when you use a good quality of cement. How you identify good quality of cement? You identify in terms of the fineness of cement. So table 3 shows minimum compressive strength of concrete cubes at 3 different ages specified by BS 4550 for Portland cement. So when we identify the strength of concrete, we look into 3 days, 7 days and 28 days. So if you can see number 1 up to number 5, number 6 is actually number 1 up to number 1, 2, 3, 4, 5, 6 is actually the different types of cement. So OPC is ordinary Portland cement. You have RHPC, rapid hardening, And then you have PBC, LHPC, LHPBC, and then you have SRPC. So for OPC, when you look into 3 days, it already achieved 13 Newton per mm squared. When OPC achieved 28 days, we will find the compressive strength is 29 Newton per mm squared. So as you can see here, the best performance is rapid hardening. It achieved 18 Newton per mm squared at 3 days, and then after 28 days, the RHPC can achieve up to 33 Newton per mm squared. So you can actually differentiate with all different types of cement with the compressive strength performance. Okay, let's look into the hydration of cement. When water is added to cement, each of the compound undergoes hydration. So this is the natural process when you add water in cement, and that will contribute to the final concrete products. Okay, only the calcium silicate contribute to strength. So tricalcium silicate is responsible for most of the early strength. Okay, especially for the first 7 days. For decalcium silicate, which react more slowly, contributes only to the strength at later times. So as you can see, calcium silicate is one component in cement. Tricalcium silicate is another component in cement, and decalcium silicate is another chemical component in cement. So each of the different types of chemical compound will contribute into the strength of concrete. Okay, let's see this picture. We do have picture A, picture B, picture C, and picture D. And this is when what will happen in terms of the components when you mix with water. Okay, let's read the title of this picture. This is the schematic illustration of the pores in calcium silicate through different stages of hydration. Okay, you must remember for us to achieve hydration process, you must add water to your cement. Okay, A, that hydration has not yet occurred and the pores or empty spaces between gain are filled with water. Nothing happened at the early stage. Okay, B shows that represent the beginning of hydration. C, the hydration continues, although empty spaces still exist. They are filled with water and calcium hydroxide solution. And number D shows nearly hardened cement paste that result into calcium silicate. Okay, if you need to look the whole process into a graph, this is how we represent the whole process with graph. We do have 4 stages of hydration process. Okay, at stage 1, a few minutes after mixed with water. As you can see, the y-axis is the rate of release of heat, and for the x-axis is the time. Okay, for stage 1, a few minutes after mixed with water. Stage 2, dormant stage, no activity observed. Okay, this dormant stage is actually at 8 to 12 hours. Stage 3 and stage 4, that will be the hydration of C3S and C3A and C2S occurred. And stage 4 is the hardening process occurred. Alright, at the end of the stage, that will be the less heat release. But from the stage 2 up to stage 4, that is the most heat release when you mix with water. Okay, let's see into the setting time is the time from the addition of water to the initial and final setting stage. It also refers to the changes of the cement paste from fluid to rigid. It involves chemical reaction between cement and water. Hydration results in the formation of gel around each cement particles and temperature changes. So as you can see, this is the process, and we look into time. Last time we look into the chemical process. For setting time, we focus on time. For type of Portland cement or PC, setting time for initial setting time in terms of minutes, okay, we need about 30 minutes, and the final setting time maximum is 600 minutes. For RHPC, the initial setting time is the same with OPC, and also the final setting time is also 600 maximum. And for LHPC, the initial setting times is 60 minutes and the final setting time is about 600 minutes. Let's see the next in terms of soundness, that will be referred to the ability of the cement paste to retain its volume after setting. So as you can see, cement when it's stained alone, it will have different volume, and when you add with water, the cement will mix with water, it will result in terms of different volume. So in terms of soundness, it is ability to the cement paste to retain its volume after setting. There is no changes after setting. That is what we want to see. Okay, the presence of excessive amount of free lime or magnesia in the cement. Okay, since slaked lime occupies a larger volume, the expansion takes place resulting in severe cracking. So the properties of lime inside the cement, okay, will actually expand when the slaked lime occupies a larger volume. It will result into expansion. So this expansion will result in severe cracking. That is why after you mix the cement or you mix the concrete, okay, you can see the cracking. The unsoundness, okay, what we want is soundness, but if you need to see in terms of unsoundness, may be reduced by limiting the MgO content to less than 0.5%. And of course, that is still relate to fineness. So you need to find fine grading cement, and then you must allow the cement to aerated for several days. And what you must ensure is to ensure thorough mixing. So that is why you need proper mixer, so that you have very good mixing when you add cement, aggregate, water and fine sand inside the concrete mix. Okay, let's see into loss of ignition. This loss of ignition is the test carried out to determine the loss weight when the sample heated to 900 degree to 1000 degree Celsius. The loss on ignition is determined by heating 1 gram of cement sample in a platinum crucible at the temperature of 900 to 1000 degrees Celsius for minimum 15 minutes. So of course we need standard method, standard lab testing to identify the loss of ignition. So you get 1 gram of cement sample and place it in a platinum crucible, and the temperature that we need to achieve is 900 to 1000 degrees Celsius, and the time taken is about 15 minutes. Okay, normally the loss will be around 2%, and maximum allowable in terms of loss is 4%. Okay, the loss of weight due to evaporation of moisture and CO2, which are present in combination with free lime or magnesia. Okay, that is actually the factor affecting loss of weight during the testing. So that is all in terms of what you need to understand for this topic. So you can read again all the slides, and you can refer to textbook, and of course you can refer to any material available in the internet for further understanding. So that is all. Okay, thank you.